So now that we're finished dyno tuning the Integra, I am now going to install the new gauge cluster that he has, which is the Link/AIM Dash cluster right here. Now, he's not ever going back to the factory cluster, so we're gonna be able to cut the wiring out here and then wire it directly. Now, Andrew has already done some prep work for me. He's ran this shielded wire here that we're gonna use for CAN bus. And that's obviously gonna go to the Link. All the other connections are gonna come from this side. Now, on the AIM dashes, we have this additional plug here, and that additional plug is like all your accessory type stuff. So we're gonna go ahead and wire all that stuff in and get that all going. So we have the dash set up here, and so the dash pre-configured from the out of the box is set up for 1 megabyte. Because we're running the AEM wideband, we had to drop the speed down to 500 kilobytes. And so I don't do a lot of this stuff, so it took me a little bit to kind of remember. But once you connect it through Ray Studio 3 and you connect it, you actually have to set up click on a new configuration and then select the dash that you have, which is this one. Then at that point, it allows us to make changes from here. So once you click on this, you basically will go into, it's in here somewhere. Let's see here. There we go. So we have to select ECU stream, and we have it at Link, and we set it at 500. Then we also enabled the 120 ohm resistor because we had a resistor wired into the wiring over there when it was only just the AM wideband into it. So now we can remove the resistor and wire it all in. And I've already tested functionality for this, and it all works here. And the thing is that once you do all this, unfortunately, like other dashes that you have, is that once you make the changes here, you actually have to click transmit, and once it transmits, it'll basically write to the dashboard there, and then from there it should all work. So now we have it transmitting right now. Once it's all done here, I'll go ahead and I'll fire it up so you guys can see that it is in fact working. And then you also have to make changes on the Link side. They give you this handy dandy instruction sheet here on how to do it, and it's pretty cut and dry. You basically are going to go into your, where is it here, CAN setup on ECU controls, and once you're here, you're going to select CAN 1, user defined 500 kilobits, and that's again because that's the AEM wideband is in line there. Then you're going to just pick a channel and literally put the AIM dash with these settings in it, click apply, and it's done. So let's go ahead and fire this thing up here, and you can see we have RPM. So RPM is really low because this tachometer reads to 18,000 RPMs, but you can see that the tach is in fact working there. All right, so just to basically remind myself, if in order to make changes of your units, you got to go to ECU stream here. So we're going to go to intake air temp. Once you double click it, the default is going to be Celsius, and obviously since we're Yankees, we're going to want Fahrenheit. So we're going to put that at Fahrenheit with no decimal place because there's really no need for that, and you can see that it changes to Fahrenheit. Now the next step is going to be the actual display itself. So we're going to go to the display here, and so we have the RPM gauge, right? You can see that the RPM gauge goes to 18,000 RPMs. Well, this thing's on a motorcycle. So we're going to click on this. It's going to have ECU RPM here, meaning that it gets RPM from the ECU. Scroll over here and you'll see that we can bring the tachometer down. This car red line's like 8,000 RPMs. We're going to put it at 10 though. That way we have a little bit of headroom. And of course, when it comes to changing it, it's literally a matter of just clicking it to 8,000 RPMs. Now speed here is this speed right here is actually coming from the display itself. And we don't want that. We want speed to come from the ECU. So once we click on this, this will highlight. So from here, we're gonna move it from that. We're gonna go to ECU. And this is set for wheel speed sensor 1. So we'll click this, and now we should have speed from the ECU. So from here, we're gonna make a couple of small changes here. Okay, so in this value here, I have map here. So we're gonna double click that. We've selected map. And now the thing is that this is going to read in inches per mercury, and there's 4 digits there, and I don't think we're ever going to be 10,000 psi here. All right, so we're back in ECU streams here. We're going to go to map. Obviously, we do not want inches per mercury. This one I'm just going to set to kPa because to me it makes the most sense. So we'll save that here. Then we'll click these arrows to go back to our display. And as you can see here, it's changed to kPa. Now, we didn't change for that. It's got 3 values plus a decimal, and we don't really need all that. So we're going to double click on this again. We're not going to put any decimal places there. Save that. And I don't know if we can change how many values there are. I think that's just a placeholder there. So that, hopefully if that goes well, that should just read nothing. So, okay, so we want to change those values. We're going to click here. Then from here, we've got to click on the device, right? This is the device that we're using. And we're going to have ECU channels here. And what we want here is probably going to be coolant temp. So we'll click ECT for engine coolant temp. That's what Link calls it. Double click on that. And now same deal there. So this is already set up in Fahrenheit, but it's got a decimal point. And again, don't really need a decimal point for coolant, I don't think. So we'll check to channels, and we're gonna go ECU streams because that's where we're getting data from. Double click water temp here, and we're gonna remove this decimal place, and obviously click save. Go back to our display here, and bam, that should be it. So this is what our current display looks like. I've got the key on, I've had the USB on. We're gonna go ahead and hit transmit here, and it's gonna do its thing. And this progress bar is going to end, and you'll see that the cluster will reboot on its own once it's done. So it's giving us the okay here, and like I said, it's going to reboot. Click OK there, and for some reason it's reading 98 here, and that is map. So that is correct. So we're basically, because the car's not running, there's no vacuum. So there you go. So now we have RPM, and again, this is map pressure here. So unfortunately, it doesn't show. I don't know if we can add a label to that or not, because I don't really like the idea that it doesn't have a label. But either way, down here we've got a label for it, and it's all working. So I think we're gonna remove this and maybe just change that to speed itself. Okay, so I made that change to speed. Now it says 0. I'm pretty sure it's speed 1, but let's check. See if we can get the car rolling here. Okay, so maybe it's not speed 1 after all. I'm gonna plug into the link and I'm gonna double check it and just see if we can get that working. So you can see here, this is the live data of the actual the dash right now, and the car is in gear, and we know, and it is moving. So in here you can see driven wheel speed is 6 kilometers an hour, but it's not actually displaying here. So I'm not sure what the ECU speed data is coming from here in the software. So I'm gonna have to dig into that and see if I can figure that out. All right, so I got it figured out. As you can see, speed is not working. And so the GP speed 1, 2, 3, and 4 are actually your wheel speed sensors. So I disconnected it from here and put our transmission speed sensor as the left front wheel, and as you can see with that, now the dash is reading speed now. So we definitely got that going there. We're going to go ahead and save that so we don't have to mess with it again, but that side is basically done. So we have the basics, RPMs, and speed done. All right, so now it's time to wire up our accessory stuff. So we've got a couple LEDs that we're going to use. We've got your left right turn signals, obviously. We've got our high beam indicator, and then for me, I think it's going to be, I think that's actually really it. We do have to do something about the charge light. Some cars are okay with not having a charge light in the dash, some do. So we're going to check that out. Basically, I'm just going to start the car up and monitor the voltage just to see, to make sure that it actually, in fact, will charge. And again, some cars will not do that without some type of charge indicator. So what I'm doing for now though is I'm just gonna start pinning these up. I'm just going to get a couple wires. I'm gonna put pins to them. All right, so I got everything pinned up here. So basically I've only got one 5-volt wire. Everything else is going to be analog inputs. I don't have any of this documented or anything. I just pinned them up and everything went in. Thank goodness for the iCrimp 1424Bs. We were able to get this amp seal connector done here. So, all right, so we're gonna do this all over again. We're gonna see which ones are high beam. So channel 1 is our high beams, and you can see that it hits 11 volts when that happens. So now that we know that, we're going to go through and rename channel 1 to our high beam. We are going to do that through here. We go to our channels, and channel 1 is our high beam. That's a voltage. We're going to put this to millivolts, and we're going to leave this as 0 to 12 volts. We're going to hit save, and that's going to save it there. So now at this point, I'm going to see if we can just skip making a custom sensor all together and see if it works. So we'll name this high beam. See, and just like before, I can't save it because there's already something named high beam. So if we put high beams, we can now save it. So this is the same deal here. We're gonna try this AD channel, high beam, okay, greater than 1000 millivolts. We're gonna hit okay there. And same deal, we're going to have LED. This is LED number 2, and we're going to change this to blue and hit save. I'm going to transmit this, and I'm just going to see if we can do it this way and skip the whole custom sensor ordeal altogether. All right, so we've already transmitted over, and as you can see, it's illuminating. If I turn the headlights on and click it, it stays on to indicate that yes, the high beams are on. So we've got the key on, we've got the left and right turn signals hooked up to our just our channels here. And so in order for us to figure out which channel is which, we're gonna hop over to all configurations here on the left, and we're gonna double click on our connected device. So this is gonna show us real-time things that are live. And so I'm gonna hit the left, then the right turn signal. So left turn signal is channel 3, and right turn signal is channel 2. Okay, so remember that. So then we've got to click on the gear icon. We're gonna head back over here. And so what we're going to do is we're gonna go and name those channels. So we're gonna click on channel here, and you can see channel 3 is our left turn signal, and I'm gonna name channel 2 our right turn. So we're gonna double click that, and we're just gonna turn that to right. So I just want this done so that way we no longer have to make a mental note of it. We know that channel 2 is right and channel 3 is our left, and then we can go back and set it all back up. Okay, so basically the settings here, and this is going to be the same for the right and the left. We're going to have this function as voltage, okay? We're going to put this at 0 to 12 volts because obviously we know that's going to be 0 to 12 volts. Our unit of measurement is voltage, and our decimal place is no decimal places because we don't really care about that. Now, I'm going to put the sampling frequency at 10 hertz for now. We may have to change this, but we've got to do some testing first. So I've got that set up for the left and the right side already. So let's go ahead and move forward. We're going to go ahead and go back to go back here, and this is actually in the configuration. So from here, then I had to go to an alarm, and this is our alarm for our left turns, and I actually had to change the name because left turn was a function and you couldn't have a function with the same name. So from here, these are the settings here. So left turn signal, this is our value, and this is a greater or less than. And so the left turn has to be greater than a constant 1000 millivolts. And then we click here and we turn this to LED, and this is LED number 1 because that's the position of the turn signal indicator here on it. And once that was done, then at that point I was able to save it. And the LED turns off until the condition is no longer met. So we're gonna, I'm not gonna hit save because there's no point to save it. Then I had to transmit it, and now we have working turn signal. Okay, so let's try to do this again. This is going to be the right turns, and we got to put S because it was not happy. Okay, so we're going to go here to AD channels. We're going to pick our right turn. We're going to click OK, and same deal here, constant after above 1000 millivolts. Click OK here. Then this is going to be an LED, and this will be LED number 5. And we're going to change this to green because that's just what turn signals normally are. Okay, so now let's transmit it. Left turn signal is working. Hopefully the right one works. Okay, and now the right turn signal is now working. So that all that's done. Okay, so a big problem that we have with handbrakes all the time is that they are basically grounded, and they're only grounded when you put the lever down. So I figured that out. I've got this one wired into channel 5, and I basically switched this to a, instead of being an analog input, it is now a digital. And what I ended up doing was I used the internal pull-up. And so now there's going to be a voltage difference when you drop the lever. So we're going to go through and we'll take a look at it here on the live data, once I can get to it. Okay, so now we're back here. We've got the live data, and we've got handbrake. Currently it's off and it's down. I'm going to pull up on it, and then you'll see that it is on now, telling us, signifying that it is showing that the handbrake is up. Now I've got to figure out what we're going to use for an LED for the handbrake. So I need to set all that stuff up, and we'll get it all working. All right, so forgive the grinding. Jeremiah's over here grinding some stuff, but I have it all set up here. Just as before, just a reminder, you can't name it the same as whatever, so I put it as handbrakes. But either way, I repurposed the light, so the low beam indicator and I kept it as red for the e-brake light. And as you can see, it works as intended. Okay, so for this, fuel level is always a pain when it comes to like these digital clusters. I had to wire what's in a pull-up, and basically I used a 1K pull-up here. So there's a resistor, and you'll see that there's the 5-volt wire here, and it's a pull-up to bring the sensor up. And now, before I removed the stock cluster, I looked at the fuel level, which was 25%, right? And so this is what about the AIM cluster I do not like at all. It's because that none of these settings can be changed live, and you have to do something then transmit it. So the value that we read off of the, if you go to the live display, so we're gonna double click on connected devices here, and now we've got our live display. So you see fuel level says 25%. Once you click millivoltage, it tells you that the voltage is roughly 146, right? So that's 25%. So in here, in the custom settings, I put 146 as 25%. So hopefully, if it works correctly, it should scale backwards. Hopefully that's not like the lowest value, but I'm not too sure, to be honest with you. But at least we know that that's 25%. So what's gonna happen now is we're gonna add some fuel back into it, and we needed to do this anyways because we needed to check our ethanol content. So we're gonna add some fuel back. I think we've got about 5 gallons over there, and then we're gonna add 5 gallons in and then see what that nets us. So according to Google, the Integra has 13.2 gallons of gas. So we divided by 4 because there's a quarter tank in here. So that gives us 3.3 gallons, right? So 3.3 plus 5 equals obviously 8.3, right? So we're going to find out what our percentage difference is really quick here, and then that should give us a rough idea of how much we should be getting on the display. Because I'm not a math agent, I had to use an online calculator, and so I put in 8.3, what we should be getting of the full, which gives us 63%. So let's go ahead and add fuel, and hopefully it goes up to 63%. Yeah. So Andrew and I had a chat here, and so here's the stock cluster, which is less than a half a tank. So we think this is not accurate, and the reason why is that because we let this car run out, and then we put about how many gallons of E85? 5. So we put 5 gallons of E85 in it. It's a 13-gallon tank, so that should only be about 30% fuel. So this fuel level probably is no good. I don't know, I don't really care at this point. Anyways, so we're gonna add this, and hopefully it levels out about 60% or so is what we're hoping. The math calculator says 62%. That's assuming that any of this is actually even correct. So we'll let it add in, and then we'll let it settle, and then see what we net. So I had to use my best judgment here, but I actually had to go back and make adjustments to this fuel scale, and even then it doesn't seem right. But at this point we're just kind of guessing, since we don't know for a fact. This number may be higher or lower, we won't know until we actually fill up the car. But right now it does read 65%, so we're going to leave it there. We'll do some further testing, and then we'll know for a fact. So fuel levels started acting up, which we kind of saw on the dyno. We just weren't sure what the actual problem is, but it definitely is not working out. So for now, we're just going to leave that as is, fill it up, and maybe something will change. But currently that's just like our little display there that we have. This is lambda, then we've got intake air temp, but I've got to change some things around. Obviously I just kind of threw this together. So the one thing is that on the 500 kilobyte version of the Lam Canada, excuse me, so the issue that we're having is that we're on 500 kilobyte speeds, and the CAN bus is not actually fully set up, and it's missing ethanol content is what it's missing. So I posted up on the support group to see if anyone has it. So we'll see how that's going to pan out, but currently that's where it is, that's where it sits, and it looks pretty damn good, I think. So we're just going to give it a functionality check here to make sure that everything is working in terms of all the LEDs. Bam. All right, so I'm pretty happy on how most of it turned out. So we've got a couple more things that we've got to handle, and then we should be good to go.